Hi, I'm Madison. I am the AI Content Strategist and Video Strategist at Tomorrow.io, and I'm here today with Jack Dallimore, our Technical Program Manager at Tomorrow.io, and we're going to be talking a little bit about the most recent satellite launch at Tomorrow, which was super exciting. So I'll let Jack introduce himself before we go down some cool questions together.
Yeah, so I'm Jack Dallimore. I'm a technical program manager here at Tomorrow.io. I'm in charge of kind of a wide variety of things on our space and sensors team, ranging from the ground segment to our satellite programs to our arena programs, which is our radar backend product line that we sell to external customers and which will power our future radar constellation.
Cool. Awesome. I'm so excited to talk all this about this with you today because for my end on the marketing side, like I get to see everything when this is all done. So I am really excited to learn about how everything comes to fruition with the satellite launch. So with that, I'll start off with some of our questions. So I first want to kind of understand a little bit more about like the satellite preparation, the engineering, and just the back end process that goes into a satellite march like we just had this March. So, one of the questions I had for you was, what are the key steps and milestones in preparing a satellite for a launch or for final assembly to lift off?
Yeah, absolutely. There's a whole ton of items that go into that. Here on our side, we are kind of we lead the program from the standpoint of making sure that all the vendors are coordinated and leading the assembly integration from a top level. We have partners that do the assembly integration and test of the satellite. And for the sounder satellites, which we have a very talented team working on, we have so many different components that go into it. So in a sense, it's kind of like building this Lego model where we have all these different pieces that are coming from all over the place, from different vendors, and we bring them all together at our one vendor that builds our bus and integrates our final satellite. And in that process, they put it all together, and then we move into kind of the next phase where it's a fully built satellite, and we go through what's called environmental testing. And that's to prepare it for the harsh environments of space. Really, what we're focusing on is, does it do well under temperature pressure? Does it do well under, vibrational environments on launch?
Mm,
And so kind of the way we refer to that is, shaking and baking the satellite. So um,
nice.
these are all in order to get us, you know, confidence that the satellite is going to perform on orbit through all these extreme conditions. Um, and then after all of that, we go through kind of final checkout and integration to the launch vehicle. So at this point, we are really essentially doing just one last final check to make sure nothing broke during that testing. And then we will integrate it to the launch vehicle. And that's basically like, putting it on the FedEx truck and saying, ready to go, and it's going to launch. And then prior to launch, we do a launch readiness review. Essentially, this is done as a pre-ship review, and we work with our ground station partners to make sure everything is ready to go from a hardware standpoint and a mission operations standpoint. That we are set for launch and we're ready to start communicating and operating the satellite.
Wow. That's like to me so cool. I also love the idea of it's just a really fancy, really expensive, kitted out FedEx truck to
Mhm.
get it up to its final destination.
Yeah.
Curious, how long would you say that you just described like beginning to end, right? And all the coordination that goes into how long is that entire process? And I'm assuming it varies every single time and different things can happen, but I'm just curious how long it usually takes.
Yeah, so we started this program roughly. We had our first launch on the Sounders program back in August of 2024, and we started the program back in 2022. So 2 years is when you start to onboard all of your vendors, get the contracts in place, start having those conversations, getting through the designs, and that's actually quite expedited compared to our some of the other competitors out there and some other bigger satellites. That's a huge factor. Just how big your satellite is will drive, how much complexity and how long it's going to take to build. So, and we were building off of some heritage with a previous NASA MIT collaboration program. So we were able to expedite that timeline a little bit.
I mean, I think maybe to, like, the average person that's not in maybe the space field, 2 years feels like a long time, but I think when we think about building and launching something to space, I think 2 years is actually pretty quick. I was expecting you to say longer, so that's awesome.
Yeah, yeah.
Okay, so next question, I think you mentioned it, but just to reiterate, what teams, like, overall are involved in the satellite process? So I know there's just so many different people, and you say, like, a big part is, like, coordinating all the different vendors, but what teams exactly are involved, in working on a satellite launch at tomorrow?
Yeah, absolutely. So at Tomorrow, we have kind of the program team that is managing all of this with from a contractual standpoint, the schedule, the budget. And then we have a very talented team of systems engineers that are in charge of the more of the technical aspects of the satellite program. They are the ones working directly with vendors, reviewing test data from all of the subassemblies, making sure that components get to where they need to be on time, and then working with our final integration bus vendor and the team that builds the space vehicle to review test data, plan out all the environmental testing, and then eventually integrate the satellite. And that's the systems engineering team. And then we have the mission operations team, which is kind of part of the larger ground segment part of the program. So space is kind of divided. Space programs are divided into two elements. We have the space element and the ground element.
Mhm.
So the team that manages the ground element is in charge of making contact with the satellite, working with our ground station vendors, and ensuring that we can continue to operate on orbit. And so we have a talented team of mission ops engineers and mission software engineers as well in house. And so those are really our whole team in house that manages this project. And then we have our ground station network providers. We have a really we have really great partners in our ground station network providers that enable us to communicate with the satellite and maintain contact and do operations. And then our launch provider enables us to get on orbit. And that pretty much encompasses all of the different teams that are involved in this process.
Cool. Yeah, it's so interesting. I also, like, I'm learning so much, like, that there has to be a ground team or that's responsible for that communication as well as the team that's, like, thinking about all the aspects of, it being in space.
Yeah.
Awesome. That's so cool. Okay, how do you test and validate, like, satellite instruments and technology? Because I know there has to be so much trials before it gets launched and, we're setting it up there. So I'm wondering, what are those tests and validation process that you have to go through before launching?
Yeah, that's a great question. A good way to think about testing a satellite and kind of testing anything in the engineering world is a good analogy is like learning how to play music. You take little phrases of the music at a time and you practice those over and over again, and eventually you put them together, measure by measure, bar by bar, and you start to do kind of more holistic testing and more holistic practicing.
Yeah.
And so that's a good analogy for the way we test satellites because there are all these different subsystems. You have your batteries, you have your solar arrays which charge your batteries, you have your communication system through your radio, you have your payload, which is capturing the data that is the purpose of your mission. And you have your payload computer and all of the other computers that manage all the data flow. So you test all of those individually throughout the process. And then as you start to build up confidence in each subsystem, you kind of do an end to end test, which will simulate a day in the life, is what we call it. So DITL is the acronym, and we use day in the life testing to simulate how we would actually be operating on orbit. And so we generally will take data collection all the way through data downlink and all of the processes that are involved in that and ensure that you are confident in the operation of the satellite.
I really appreciate a lot of, like, the way that you make these metaphors and are explaining everything to me. Because again, like, I have so much interest in this, but I don't have, a, like, aerospace, engineering degree. So you breaking it down in this way, I really appreciate. I think it's really I mean, that's a great way to break it down. It's like music. I think a lot of people, even if they've never learned an instrument, probably know it's, like, by the slow implementation and adding and building. So that's a great way to look at it, so I appreciate all the analogies. It's great for someone on my end who's just trying to learn more about it. Okay, final question about just kind of more of the back end process of satellites. What are some unexpected challenges or technical hurdles that can arise during the final prep stages of getting a satellite ready for launch?
Yeah, definitely. There's a whole host of issues. You know, the thing that is probably the most difficult about launching a satellite is that there are so many different subsystems that play different functions of the satellite that all need to work together. And so oftentimes you'll have, software that is running on one part of the satellite that might been developed by a different team that developed the software for the other part of the satellite. And so you need all of those things to be able to talk to each other. So the thing that I always say makes complexity in satellites, and in launch vehicles and in pretty much any other engineering hardware, is the interfaces. The more interfaces you have, the more complexity you have. So the more you break it up into different subsystems, you often are introducing certain complexity.
Mm,
Um, and so little things like that tend to manifest in some, generally sometimes they're simple issues, sometimes they're more complex issues. It could be as simple as a connector is loose, right? So that's an interface, but you need to connect two different systems together through a cable, and maybe a connector is just loose and you're not getting the signals properly over that interface. Or maybe it's a bug in the software, or potentially one of your pieces of hardware wasn't qualified to survive more than the cycles that you've been testing it. And maybe there was an issue with the requirements. So you end up having all these different issues compound, and sometimes it's very difficult to find the root of the issue. You oftentimes are spending lots of times troubleshooting, figuring out, what are the symptoms of the problem, but actually what's the underlying cause of the problem.
mhm,
And so, yeah, it's a good test of patience for the whole team.
I bet.
But also a lot of perseverance, I would say, is what people learn through this process. It's very, very much a grueling endeavor.
Yeah, and it sounds like just like a big team effort too, right? It's like everyone has to be working together all across departments and different aspects of the creation process. And like if one part's going wrong, it's not just like that one person or that one team's problem. It's like everyone has to step up and figure out how to resolve it. So I mean, yeah, that I can only imagine the different things that you have to be figuring out, throughout the process, but it's really cool that, like, you all have to work together and figure it out. I bet there's a lot of learnings every single time, probably, like, both engineering-wise, but also maybe, like, personal life lesson of, "Okay, we gotta really work together and get
Yeah,
through this."
totally. And not yeah, and to continue the music analogy, I mean, it really is like an orchestra. Like there's a lot of different people doing different jobs, and it requires, timing, and it requires an emphasis on quality. So
Oh, yeah.
yeah, there's a lot of elements to this.
Yeah. Launching a satellite is like an orchestra,
Mhm.
like, from beginning to end, learning music all the way to the finale. That's a great analogy.
Yeah, no joke.
Okay, so moving on, I would love to understand a little bit more about like, especially when we're now getting to okay, we just did the back end. I want to learn a little bit more about like why delays happen and how we can like manage more risks. So satellites built, now we're ready, kind of ready for launch. So now I'm pivoting to that. So I want to ask you a few questions on that end. So what are the most common reasons a satellite launch might be delayed, and what specifically caused delay for tomorrow's latest launch?
Yeah, good question. The launches can be delayed for pretty much three main reasons. Weather conditions. So, something that our company could help with. um, weather conditions. The technical issues could arise on the launch vehicle, or technical issues would arise with the satellite. Those are the three main reasons. I would add in a fourth reason is the pad availability. So the launch pad availability is, if there's a launch before us that is delayed for any one of those three reasons, that is likely going to push our launch. And that's exactly what happened in this situation. The Transporter 13 launch is that we had a launch before us, the NASA Sphere X launch, which was pushing due to weather conditions for part of the time. It was pushing due to technical issues with both the launch vehicle and the satellite for other parts of the push. And so those slips built up, and it takes time to turn a launch pad around. So the launch pad at Vandenberg takes a couple days for them to prepare for the next launch. And so ours launched about 3 days after the NASA SphereX launch went off from the same pad. So that's really the primary reason for our slips this time.
Okay.
Um, yeah.
You know what I also didn't realize? I didn't know, like, launch pads were shared. Like, this was
Yeah.
something really interesting for me to learn. I didn't know that, we share it with NASA and other people use it. So, like, yeah, it makes sense. Like, if one person's delayed, then the whole line behind it has to wait. But I just didn't
Mhm.
know that that, you share them. But I guess, common knowledge. I'm just like, oh, they launch from, a launch pad somewhere. I just didn't realize it's usually like when we're watching different videos, something launching maybe from different companies or different space companies. It might actually just be all the same launch pad, just at different times and different use cases, which is really interesting for me to learn. So when a delay happens, like what does the team focus on during that extra time? So in this case, it was kind of like out of your control, but I know you mentioned like there's other reasons why something can be delayed. So what happens when it's not a timing thing, like a delay caused by another team using the launch pad? So what would be the focus? Like what would be the next move if you're feeling like the delays are from something else?
Yeah, if delays are due to any issues with the launch vehicle or weather, we would honestly just take the rest of the time to rehearse and prepare for mission operations. There's nothing much left to do on our spacecraft at that point. You don't have contact with it, it's already integrated to the launch vehicle. Um, Conversely, if there is an issue with our satellite on the launch vehicle, we are in the situation where we are part of a rideshare. So we are on the vehicle with upwards of 60 other payloads and other customers. Um, and so with that being the case, they don't necessarily want to delay the launch for only one customer not having their satellite in order or something going wrong. But if it is a serious enough issue that might affect other customers, they will delay and we will have to fix the issue. So if that is the case, then we're going to have to troubleshoot what that issue might be. And that can take many different forms, like we've discussed. Yeah.
Yeah, wow, I also, love that it's called rideshare, this makes me think of, like, an Uber or, like, a Lyft
Mhm.
rideshare. I also didn't know that either, that, there's multiple companies and devices on that one going up to space, so that makes a lot of sense, right? It's a lot of effort to get a rocket up into space. You don't wanna just send one thing with it, you probably wanna take advantage of it as much as possible, but I think it's funny
Yeah.
that they both share the same name, me Ubering to a restaurant with some other people on a rideshare versus satellites launching to space. That's funny. Okay, I think we kinda covered all those questions, so I think I'll move on. So I wanna look ahead and also kind of your own personal insights from, this most recent satellite launch and then the other ones you've been a part of. Um so what part of the satellite launch preparation process do you find the most exciting, and which one do you find the most stressful? Which sounds like a lot of it can be stressful, but I bet there's probably one thing that, maybe grinds you down the most.
Yeah, I would start with the stressful. It is, I mean, the whole launch prep process in general, everything from the moment you start the program to the moment you are on the launch pad waiting for launch is pretty much one long uh, expenditure of energy. It is all very much you're giving your all, your whole team is giving all, you're solving problems. It's exhausting.
Yeah.
It's yeah, I mean it's enlivening. You learn a ton. And it's all for the goal at the end of the day to get that thing off the pad.
Mhm.
Uh, and so I would say truly the most exciting part of the launch prep process is the launch prep process being over. and
Yeah, I bet.
and yeah. And the moment that you make first contact with the satellite is easily the most exciting moment of the whole thing. And getting to watch your satellite deploy from the launch vehicle, as we
Yeah.
just did last week,
Yes.
seeing that thing sail away from the second stage of Falcon was, incredibly exciting. And
Uh,
then we made contact with it only an hour later, and we're able to start getting data down. And that is
wow.
uh, very much a culmination of all of your effort wrapped up into one moment. So it's
I
very
bet.
exciting.
It's interesting too, because it's like, I thought you were gonna say, like, when it's launched is the most exciting one, but it's like, no, it you still have that in kind of anxiety until you have that, like, it releases and you have that first point of contact, which you already answered. My follow-up was maybe like, how long does it take to get, like, a first point of contact, which is only an hour later, which is crazy. I remember seeing the video, like, the satellite leaving the rocket, and I was like, "Wow." Like, working at Tomorrow is such a cool company to work for. I'm always like telling my friends, being like, "Yeah, like we just launched some satellites into space." And they're like, "What?" But yeah, I can imagine the whole thing just seems really stressful, but obviously equally very rewarding. So that's really cool that that's the rewarding moment, is that first point of contact when it's up in space and you can finally get some data back from it. And then final question, is if you could explain one thing to the public about what it really takes to get a satellite to space, what would it be?
Yeah. Um,
How's our
I was thinking about this one a little bit. Uh, the the process is very much um process of getting a satellite to space is similar to, um let's call it, training for the Olympics, or like climbing a very technical mountain. You kind of see the path from a high level, and you say, oh yeah, I'll do this and this and this. And um each step along the way has a different um you know uh different requirements, and you are kind of training for that eventual summit or that peak moment, right?
Mhm,
um and as you start to go through that process, you realize there's a lot of little technical details along the way. I mean, if you've ever hiked in the mountains before, maybe there's a path that you were planning to take and it's under construction,
me
or
too.
there's it might have gotten washed away by a landslide. I'm not sure. But there's there's you have to detour. The point is there's always a detour. There's always bumps in the road, there's always slips, you know, these things are kind of well known by people. But once you go through the process, I think that's when you truly know it,
Mhm,
how difficult each of these steps can be.
yeah,
And so I think that's kind of the the thing I would like to convey about it is, people spend years and years of their life dedicated to one mission, and to see that moment when it is launched and you do make first contact is, multiple years wrapped up into one moment, as I said. That's very, very exciting for everyone working on it, and I think that it behooves people to remember how much time and energy and love went into each of those steps of the process.
totally. It's like getting the gold medal, like a retro
Yeah.
Olympics thing. Yeah, it's like there's a lot of work that goes into it, but when you accomplish it, it's like probably pretty emotional and pretty amazing. Well, thank you so much for taking the time to speak with me
Yeah.
and answer some of my questions. This has both been very informative for myself, as well as I hope for those who are watching this. And yeah, thank you so much for all the work you did for the satellite launch. We're so happy that it went well and it's successful. And yeah, I really appreciate you taking the time to speak with me today.
Yeah, absolutely. Well, we have a great team, and I appreciate you taking the time to talk to us.
Awesome. All right. I think we're good.